So with our homework that is due Monday, we're looking at lines of best fit. Here's our first graph that you're asked to look at on the front page. We're going to scale each one of these boxes by 5 on both the x-axis and the y-axis. So down here we have 15, 20, 25. I'm going to skip every few. This is 35, 45, 55, 65, 75, 85, 95, ending with 100 right there. The same will go for our y-axis. I'm going to label it every just 10 on our graph. Alright, so now we're going to graph our points. First one, 8, 11. So 8's right about here, 11's right about here. Our next point, 16, 13, so 16, 13. 22, 23. 30. So here's 30 right here, 21. 33, 36. 33, 26, sorry. It's right about here. 43, 29. 43, 29. 51, 35. 63, 47. And then we have 81 and 51. Okay, so here are the dots that we got from the table. We do have some empty boxes here. This one's looking for an x coordinate. This one's looking for a y coordinate. But before we can get those two, we have to draw our line of best fit. Okay, so let's look at what the homework questions were. Question number 1 was, what correlation is found in the scatter plot? Well, if we take a look at the dots right here, they are rising up to the right. And when we have up and to the right, that leaves us a positive correlation. Positive correlation when the line and the points slant in this direction. The second part of the question is, what conclusion can be drawn? Well, the conclusion is all just asking for context. So it's just asking for a context. The context is all about the variables that are going on in the problem. This particular problem is all about length and width right here. Length and width. That was not my greatest circle. Okay, so a positive correlation says that as one increases, so does the other. Well, all we have to do is get more specific to answer our second part of the question. We just have to use the two variables listed. So, as length increases, so does weight. And that is something that we see happening with the data points themselves. Here we had 8 and 11. By the end, 81 length was 51 weight. Everything was increasing as we went down the chart. Question number 2 says to pick 2 points to use for our line of best fit, record the 2 points, and draw the line. So here I'm going to draw our coordinate points. We are also able to record them in a table. So I need to draw my line of best fit. The line has to go through the middle of the data and have about the same number of points above and below. So the best thing to do is to pick 2 points from the start. So I'm going to pick the first point and the last point. I'm going to see if that works. I'm going to draw my line from my first point to my last point. And we're going to see what happened here. We have, I think the line does indeed go through the middle of the data. I have 1, 2, 3 below, 1, 2, 3, 4 above, so that's not bad. I'm going to, so we come back to that one. That might be a good choice, but it's always good to try multiple different ones. So I'm going to try again. Let's say instead we do the second one and the second one. If we do that, we draw our line through both the points. I have 1, 2, 3, 1, 2, 3, 4. Not bad either on that one. You can go back and kind of compare it to the first one. I'll use one with a different line. Let's say orange. So we have to kind of look at it, which one would have a better, which one flows better with the points. Looking at both of them, the orange one is able to get really close to this last point right here, and every point around it is very close, while the black line has a decent space away from our last point. So I actually think the best line that we came up with was our first choice. Luckily, it was our first point and our last point. I'm going to make sure I draw my line all the way across the page, going through my 2 dots right there. I'm going to move that out of the way over here. Okay, so here's our 2 points that we chose. We drew our line. All we have to do is record our 2 points further into our problem. I'm just looking at our line. I think maybe could do better. Maybe I'm thinking a line. Oops. Right about here, maybe. Would be pretty good. No, I like our first one. Changed my mind. Okay, so let's record our 2 points. The first point was right here. Oh, I didn't move this back 100%. Right about there. First point was the 8, 11. Oops. And the second point we chose was way over here. It looks like it was the 81, 51. 81, 51. If we were recording it as 2 coordinate points, they would be written like this. Question number 3 asks us to estimate the where does the line cross the y-axis? So this is asking for our y-intercept. So we go back, we look at our line, crosses our y-intercept right, or our y-axis right here. I'm going to estimate that to be just about 6. Record it as an ordered pair. So as an ordered pair, the y-intercept is 0, 6. Looking at our graph, 0 on the x-axis, but 6 on the y-axis. What does that mean in the context of length and weight? Well, it's the same thing we had before. This is an x, this is y. So in our table, length is x, weight is y. So this means that length is 0, but the weight is already 6. So whatever object or thing we're talking about carries weight without having any sort of length. Question number 4 is to write our equation of our line of best fit. So we have y equals blank x blank. Here's where we need our slope. Here's where we need our y-intercept. We already know our y-intercept. That was 6. So we get that number for free. We then have to fill in the slope, which means we have to come to our table. From 11 to 51, that's a change of 40. From 8 to 81, that's a change of 73. Rate of change is fraction of rise over run, or y over x. So our equation says 40 over 73. We cannot simplify that, so we're going to leave our equation right here. We're now going to try to fill in these empty spaces right here in our table. So starting with the 38, 38 is a given x value. So we find 38 down here on the x-axis, right about here. 35, 40, I lied, it's right about here. Gotta look at my scaling. It's right about there. So we go straight up from this spot until we get to our line of best fit. So I hit it right there. Go straight across. And if this is 20, 25, 30, right about halfway between it, I would say something like 27. $65 is in the y column, so we find 65 on the y-axis. It's right here. We go straight across, straight across, straight across, straight across, straight across until we get to our line. Our line doesn't quite reach it, so we're going to extend it just a bit. So here's where they meet. The top of this graph was 100. So if we go a little bit further, maybe 102, 103, 104, roughly for our estimate. So we'll say something like 100. and 3. The last two questions ask us to find two numbers based on the line equation. So our line equation was 40 over 73x plus 6. In this case, they're asking about length. Length was 40. Well, if length was 40, or 140, I'm sorry, 140, what they're really asking for, since it's a length, is they're asking us, or they're giving us, x. Since they're giving us x, we're going to plug x in right here. So y is equal to 40 over 73 with 140 in for x plus 6. Simplify our fraction here, so we're going to multiply 40 times 140. Grab a calculator here. So 40 times 140, and we get 5,600. We divide that by 73, and we get 76.71. So we're going to estimate that as just 76 point, and then to one decimal place, so a 7. The 1 causes the 7 to stay. Then all we have to do is add 6, and 76.7 plus 6 is 82.7, and that's the weight. Question number 6 is just like the other one, but this time they've told us a weight. So I'm going to use my same line equation that we came up with. But when weight is 120, what they're really giving us is y. We're going to take this number, 120, and this time plug it in for y. The rest of the equation is exactly the same. It's unchanged. Two-step equation. Subtract 6 from both sides. That gives us 114 is equal to 40 over 73x. The fraction is connected to x by multiplication. So we're going to break this multiplication, but instead of dividing a fraction by a fraction, I don't want to do that. We have a nifty little helpful trick that we can multiply by what's called the reciprocal, or the flipped version of this fraction. I'm going to do the same thing to the other side. 73 and this 73 cancel out because 73 divided by 73 is 1. 40 divided by 40 is also 1, leaving us just x. On the other side, I'm going to multiply 73 times 114 and then divide it by 40. So clear out the calculator. 114 times 73 gets us this really large number, 8,322. Divide it by 40, we get 208.05. Since the decimal did end, I'm just going to write the whole decimal. So it's 208.05. So that was the length when weight was 120. The second problem was all about miles and energy. You were asked to scale it like this. So we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This side we're scaling it by 2s. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, ending with 40. Plot the points. So we have 133, 228, 223, 325, 317, 419, 521, 515, 6, 9, 7, 12, 8, 5, and 9, 7. Once again, it has 2 blank spots for us to find. They gave us a y, they gave us an x, so we're going to have to do the same thing we did with the last problem. We'll come back to that. First question, what correlation can be found? The points are not sloping up and to the right. Instead, they're sloping down and to the right. And down and to the right is negative. Negative means it's the opposite of what positive is. We all know that. So when you ask about the context, as blank does something, what happens to the other? I'm going to let you fill in the blanks on your own for the homework. As what increases, or as what does something, what does the other do? Gave you a little bit of a hint on that one there. Question 2 asks us to pick 2 points to draw the line of best fit and record the 2 points below. Okay, so just like before, we're going to make our table. Let's go pick 2 points that we think might work. Again, let's start off with the first point and one of the last points. Let's say this one. Let's see what kind of line this one gives us. Starting kind of there, through the first smiley, through the second smiley, all the way through. All right, let's see how that worked. I think it's a good slope, good steepness, good flow with the points, but I have 1, 2, 3, 4, 5, 6 dots below, 1, 2, 3 dots above. So those are not the best choices for our line of best fit. We're going to have to start over. So maybe instead we do this point and this point. Draw our line through our smileys like that. I think that's still a pretty decent slant of the line. But we have 1, 2, 3, 4, 5, 6, 7, 8 above now, 1, 2 below. So I actually made it worse doing that. Yikes. Start over. maybe instead we do this point and this point. See if that helps us out any. It's a bad starting of my line there. Right about there, maybe. That was pretty good. Okay. Let's analyze it to see if it's a good line. We have 1, 2, 3, 4, 5 above, 1, 2, 3, 4 below. I think that's pretty good. It has a overall steepness or slope slant to the points. I mean, we could mess around with it a little bit. Maybe go through that point. There's still too many points below. I think that was a pretty decent line right there. Okay. Now that we have that line, the points that we had were 2 and looks like 23. So on our table, to 23. The other point was 9, 7. While we're here, let's find the rate of change. From 23 to 7 is negative 16. From 2 to 9 was 7. So our slope is negative 16 over 7. So we lose 16 energy every 7 miles. Cool. Where does the line cross the y-axis? So again, looking for that y-intercept. Need to record it as an ordered pair. 0, something. So let's go look at our graph. 0, well, that's 28. It's almost perfectly 28. So we're going to go with 28. That's next page. So what this means in context, 0 is x, that was miles. 28 is the energy. What that means is that before we run a single mile, we start with 28 energy, whatever that happens to be. If we want to talk about science and joules and things like that, 28 energy for 0 miles. So 0 miles. We have 28 energy. Record the equation. Well, we've got the two pieces on 2 of our other problems. We just got our y-intercept. It's 28. Our rate of change, which we found right here, is negative 16 over 7. Using our line, now that we have it graphed, we should be able to fill in these blanks. Let's start with the 4.5. Once again, that's an x. We find 4.5 on the x-axis right there. Kind of struggling to get to that middle part right there. We go straight up from 4.5. Go straight across. It's almost 18. I'm inclined, I just want to write 18, but it's not perfect, so I'm going to say 17.9. This next one's a little bit tougher. 0 on the y. It's right here. Because it also feels like it's on the x-axis, we want to go up to the line, but we need to find the x value, so we need to stay on this x scale here. So we're actually going to go straight across. Cross is right about there. That's 12, not quite 13. I'm going to say 12.5 for myself. Last two questions, of course, using our line equation, y equals negative 16 over 7x plus 28. So if miles were 25, so miles was 25, miles was x, so we're going to plug 25 in for x. We get y equals negative 16 over 7. We've plugged 25 in for x right there, plus 28. I'm going to leave the rest of it up to you to solve. Simplify this so it says y equals. And the last question on the entire homework, using our line equation once again, negative 16 over 7x plus 28. We're going to plug, oh, this one says energy was 14, which is y. So we're going to take that, replace y with 14. Then we're going to solve this equation. Again, I'm going to leave that up to you. It is okay to get decimals on both of these, but round it to 1 decimal place. 1 decimal place. And that is how we use line of best fit to evaluate some numbers, both by looking at the graph as well as just using the equation of the line that we have drawn.